just do with my pen? There it is. Okay. All right, so your notes file looks like this. Go ahead and open it up. Yesterday we talked all about angles and arcs. Today we're talking about the segments inside of circles. Okay. All right, so we got this first one. We know this one already. We know that two tangents from an external point are congruent to each other. So if we were going to solve this one out, we would do 2x plus 10 equals x plus 10 because the tangents are congruent. So we've got x equals 9. All right, that's a theorem you already know. The next one you also already know. Go away. When a tangent meets at a radius, those two lines become perpendicular. When a tangent and a radius meet at the same point, they are perpendicular to each other. So then to solve a problem like this one, you would use the Pythagorean theorem. You work that out and you'll get x equals 6. Okay. New stuff. When you have two secants that meet at an external point, kind of like the two tangents did, they have a special relationship pattern that happens. You can find each of their pieces with the formula here. Whole times outside equals whole times outside. All right, so what they mean there, so whole of one secant would be that whole part. And then outside of that same secant. And then the same thing happens on the other side. Whole times outside. So each half of the equation is one separate line. Okay, so we would do 7. Nope, not 7. The whole secant is not 7. The whole secant is 10 times the outside is 3. And the whole of the bottom secant is x plus 2. And the outside of the bottom one is just 2. Whole times outside. So the left side's easy. That's just 30. On the right side, you have to distribute. That's 2x plus 4. Two x equals 26. So x is 13. So notice these two secants are not the same length. One is 15 units and one is 10 units. And that's okay. They're not going to be the same length. But this formula, whole times outside, does work. Okay. I actually want you to scroll to the next page. We're going to do an example from that same topic. Theorem 2. On the left, they have a big wordy version of the theorem, but I like whole times outside equals whole times outside. But if you want to read that and understand it, be my guest. We're going to do number 2. Find OG. So whole times outside equals whole times outside. So if we do the top one first, what is the whole? Ethan. Close. 6 plus x. What is the outside? 6. Okay, if we looking at the bottom one, what's the whole? Good. And the outside? Okay, so that's your setup. So the first one we're going to distribute, so it'll be 36 plus 6x. The second one is just multiply 208. 6x equals 172. X equals 28.6 repeating. Okay. Any questions there? Whole times outside? Okay. Scroll back up. We're going to do number 3, or actually this is 4. A secant and a tangent. The formula is slightly different. It says whole times whole. That's for the tangent because there is no inside outside. So it's just whole times whole, but you can still think of it as whole times outside, where the whole is x, but x is also the outside. So I don't think of a different formula when I do this one. I just remember whole times outside. So if we set this up, if we do the bottom one first, the tangent first, it would be x times x. X is the whole part, and it's also the outside part. And then the top line, whole would be 10, and outside would be 4. So we got x squared equals 40. So x is the square root of 40, or if you want to simplify that, it'd be 2 root 10. So still remembering whole times outside. So when we have an intersection outside of the circle and we're looking for segment parts, whole times outside equals whole times outside. Let's look at number 3. Again, they've written the theorem for you if you want to read it, but it says the same thing. Okay. Starting with let's do the top one first. What is our whole? So starting with this tangent. Kelsey? 10. Whole is 10. Outside? Also 10. Whole of the bottom line? X plus 6 or 6 plus x, sorry. And outside of the bottom line? 6. So whole times outside, whole times outside. So we've got 100 equals 6x plus 36. Hmm. 64 divided by 6. And here we have another fraction. So it's 10.6 repeating, or 10 2/3. Okay. So one formula to remember if you have an outside intersection point. Whole times outside equals whole times outside. The next one, back up to the top page, has an inside intersection point. When we have two chords that intersect inside, the formula is piece times piece equals piece times piece. Now, just like before, the two pieces on either side of the equals have to be from the same line. So if we do that piece, so we do the x with the 2, those two go together on one side. 4 and 3 would go together on the other side. Hi. Thank you. All right, so the setup looks like that. X times 2 equals 4 times 3. So x equals 6. And again, these chords are not necessarily going to be the same length. The way they drew it here, it looks like it could be, but you could have a chord real tiny like that and then another chord intersecting that's a way bigger. So the chords don't have to be the same length. This formula will still work. Part times part. All right, let's scroll to, actually it's number 1. So the first theorem on this page was that same thing. If 2 chords intersect, then the products of the segments of the chords are equal. So if we do dB first, what's my equation? Addie? Oh, that's x minus 1, but yep. All right. Lily, what would be my equation for CA? Good. X plus 3 times 4. And it doesn't matter the order you multiply because multiplication is commutative. So order doesn't matter as long as the segments you have together are on the same line. Three plus 6 equals 9. Okay, I did something wrong because that's not the answer I got this morning. That's what I did wrong. This is supposed to be 12. So x equals 3. Right? Those are your chord, secant, tangent line theorems. Kip. Look at that. Thank you. Plus 6 on both sides. 9's correct. So now you have the skills to do the rest of the assignment that I gave you yesterday. So far, we've found 2 problems that are not totally solvable. They got to a point where you could get an equation, but we couldn't solve them out. I want to say 15 and 18, but I erased it. But so if you get to a point where you're like, okay, I can't solve it from here, don't feel like you did something wrong. It might just be the problem. But that's what we're going to work on for the rest of the time, since now we have 40 minutes of class. And then the review activity that we do tomorrow, we'll make it fit into 20. Okay, questions or concerns? Okay, those of you at home, make that schedule's going to change for tomorrow again, so make sure you've got that. It was in the stream if you didn't see it.